Hello everyone. In this video we're going to be solving an interesting exponential, well actually it's not exponential, it's kind of like a non-standard equation which is half exponential and half linear. The reason why it's called non-standard is because we don't have something that we can solve in analytical ways like a polynomial equation or just purely exponential and stuff like that. So we have 2 to the power x equals 4x, and we're going to be finding the x values. Great, and I'm also going to share with you a result from Wolfram Alpha at the end of the video. So that's also going to show you the graph. So we have an exponential function, 2 to the x and 4x on the right hand side. So one of the things you can do when you see a non-standard equation, try to guess, because you can't solve it analytically, so you could start with guessing some of the solutions. And if you look at 2 to the power x, it's a power of 2. So you might want to have something else on the right hand side. So this also means that x is a power of 2, right? Because if you think about it, you have 2 to the x and 4 is a power of 2. So that must be multiplied by another power of 2 to make a power of 2. Make sense? So x, if we have obviously an integer solution, then x must be a power of 2. So you can test some powers. For example, what happens if x is equal to 1, right? Obviously, x equals 1. 1 is a power of 2? Yes, of course, 2 to the power 0 is 1. So 1 works. But if x is equal to 1, then you get 2 to the power x. In other words, if x is equal to 1, then we get 2 to the x equals 4, and that implies x equals 2. If x is equal to 1, then x is equal to 2. That's not going to work. Obviously, that's not good, right? So let's try some other numbers. How about x equals 2? If x is equal to 2, then we get 4 times 2, which is 8, and that means x is equal to 3. So when x is 2, x is 3. That's interesting. Again, they don't agree with each other, so that's not a good thing to do. What happens if x is equal to the next power of 2, which is 4 in this case? Obviously, I'm not going to test 3 because 3 is not going to give me something good. But what if I try x equals 4? Then if x is equal to 4, then I get 16. 2 to the power x is 16, and this implies x equals 4. So if x is equal to 4, then x is equal to 4. In other words, x equals 4 is a solution. But the million-dollar question is that the only solution? So in this video, I'm going to go ahead and show you a method you can look at these kinds of equations from an interesting perspective, which is called Lamberts W function. So that's what we're going to use. But before we can use it, I want to give you a couple definitions, and we'll work our way there. So x equals 4 is a solution given. It's all good, but we're looking for other solutions. Okay, so how do we approach this problem? First of all, what is Lamberts W function, right? Lamberts W. I've done a couple other videos on Lamberts W. Hopefully you can check them out. Anyways, so Lamberts W function works like this. It is actually the inverse of, so if you have f of x equals x times e to the x, the inverse of f is called Lamberts W function. Make sense? So what is that supposed to mean? It just means that if you input x e to the x into Lamberts W function, you're going to get the following. Let's go ahead and try that. What happens if you replace x with x times e to the x? So you got to do it on both sides. We get f inverse of x e to the x equals w. I'll probably write the w on the left hand side. It's better that way. So I'm replacing x with e to the x times e to the x, but writing this on the left hand side. So that's going to be w x e to the x equals f inverse x e to the x. Well, we do have an expression for this actually. Why? Because of this. Remember the way we define f and its inverse. So if f is equal to that, then I can basically switch these around and get f inverse of x e to the x equals x. So this is equal to x. Forget about the f inverse thing. We can directly write this as a result, which is going to be helpful in our solution. W x e to the x equals x. So in other words, Lamberts W, or you can just call that W function, or just Lambert, whatever, is something that takes x e to the x as an input and returns the x. So if you can write anything in this form, then its output is going to be fairly easy. Make sense? Let me give you some examples. What is Lambert's, or what is W to e squared? Well, you probably noticed that x is 2 in this case, and the result is x, so it's 2. Make sense? What about W of e? Well, I can write the e as 1 e to the power 1, and that would be 1 by the very definition of Lambert's W function. Make sense? Cool. Obviously, there's a couple other things that you can write with this, but I'm just going to stick to this for now. All right, cool. Let's go ahead and work our problem this way. So I have 2 to the power x equals 4x, and I need to use Lambert's W function. Now you might be asking, like, what does this have to do with this type of relationship, right? Well, we're going to put it in that form. So let's go ahead and do it. First of all, I'm going to replace, because I do need something like x times e to the x. I'm going to need to put the 2 as e to the power ln 2, and then to the power x equals 4x. And I'm going to distribute e to the power x ln 2 equals 4x. Now, this is the very critical part. We're going to put the x and the e together and put the 4 on the other side. And you want to bring this to the right-hand side, the e, not put the x on the left, because you want to stick to x. You don't want to turn it into 1 over x. Make sense? But this can be taken care of. The e can be taken care of easily with a minus sign. So that's the idea. Make sense? So we're going to do the following. Multiply both sides by e to the power negative x ln x, 4 times x times e to the power negative x ln x. The reasoning behind that is we want to get a number here, a constant. And that's a 1, right? Because if you add these exponents, you get e to the power 0, which is 1. So that's 1. And then from here, I get 4x e to the negative x ln x. And that's my expression. Let me go ahead and switch these around. So let's put this on the left-hand side, because that's like contains a lot of variables, and the poor number 1 on the right-hand side. Cool. Now, we still got some work to do, right? And how do we handle this? By the way, I just turned the ln 2 magically into ln x during the process. I don't know how that happened, but I just kept doing it. Okay, let me go ahead and clean this up real quick. So this is supposed to be x ln 2, and then here also x ln 2, and obviously here as well, that's going to be x ln 2. Great. Now this is good. Now notice that I kind of have the x and a to the power something. Again, we're going to fix it. But here's the thing that we need to worry about. I need something like x e to the x, or t e to the t. The second one is probably better because I already used x. So now my exponent t is determined by this. So this is my t, right? You like t? Okay, that is my t. But this is not t. Make sense? So we're going to turn it into t. How can you do that? Magically. It's not magically, it's kind of mathematically. So here's what you need to do. Multiply both sides by negative ln 2, multiply by 4x times e to the power negative x ln 2. I don't know why I want to write ln x. And of course you have to do it on the right hand side as well. Make sense? Now, this is good. You can go ahead and put these all together, but there's an extra 4 that you don't want. So let's get rid of that by dividing both sides by 4. So here's what we're going to get from here. Negative x ln 2 multiplied by e to the power negative x ln 2 equals negative ln 2 over 4. And isn't this like beautiful? I think it's beautiful. Why? Because we got t e to the t. Do you see that? That's what we were looking for. Now we're going to do the following. W both sides, and whatever that constant is, let's call this c, wc. Sorry about the negative connotation, but hopefully you get the idea. This is going to be t. And then from here, we're going to solve. Make sense? So here's what we're going to do next. we're going to W both sides. So W negative x ln 2 times e to the power negative x ln 2 equals W negative ln 2 over 4. Awesome. Now, this is going to be negative x ln 2. By definition, like I said earlier, W of x e to the x is x, or W t e to the t is t. Okay? For that reason. Now, we're going to leave it at W, of course. And then, what we need to do now is divide both sides by negative ln 2, and that's going to give you the value of x. Of course, this is going to be the other value of x, which is not found right away, but this is the other solution. Let's go ahead and take a look at the graph real quick, and we'll conclude with that. And the value is actually about 0.9. If you're wondering what that looks like, the x is going to be about 0.3, and we already found x equals 4 as an integer solution. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.